Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today, in our 384th episode, we have a bunch of news, including tons of awesome dinosaur tracks to talk about. We also have an update on those dinosaur tracks, which were damaged due to backhoe driving a couple months ago. We also have an interview with Thomas Halliday and Dinosaur of the Day, Adeo Papasaurus. But before we get into all of that, as always, we like to thank some of our patrons for helping to keep the podcast running. And we have 3 new patrons to thank this week.
All right.
We've got Cliffosaurus and Jesse, as well as Histologysaurus. And the histology part is because they're a histotechnologist doing histology on humans, but not dinosaur bones.
Still really cool.
It is really cool. Then rounding out our shoutouts, we've got Miriam, Elias, Ayumi, Melina and Manoli, Ayrton and Everett, Evelyn and Frankie, and Achelosaurus.
Thank you so much, everybody, for being our patrons and being part of our dinosaur community. All right, as Garrett mentioned, we have a lot of articles around dinosaur tracks. And I'll start with this one that was published in Scientific Reports by Pablo Navarro-Lorbes and others, and it's about fast-running theropod tracks from the early Cretaceous of La Rioja, Spain. Researchers found 2 trackways that show some of the fastest-known theropod tracks. Yeah, they looked at 2 theropod trackways in the Enciso group, and again, this is from the early Cretaceous, and they compared them to other fast-running theropod trackways. Now, the first trackway had 6 footprints. However, only 5 of the footprints were preserved because the 3rd footprint in the track was in a spot where the top layers of the rock had been lost.
Yeah, that happens.
Yeah. The footprints were almost 13 inches or almost 33 centimeters long and about 12 inches or 30 centimeters wide.
So the foot was about a foot by a foot, is what you're saying?
Yeah, that's a good one. And the second trackway had 7 footprints that are longer than they are wide. So that was like 11 and a half inches or almost 29 centimeters long and about 10 and a half inches or 27 centimeters wide.
Gotcha. So they're both longer than wide.
Yes.
But the first set was a little bit bigger.
And based on how the footprints looked, they're 3-toed tracks, to make sense, they're theropods, and based on the Iberian fossil record, it could be that these tracks came from a basal tetaneuron, probably a carcharodontosaurid or a spinosaurid.
Ooh, that's cool.
Yeah. They estimated the dinosaurs were around 7 feet or 2 meters tall and around 13 to 16 feet or 4 to 5 meters long based on the size of the prints. And they analyzed their speed based on the hip height and stride length, and they found that the speed ranges went up to 27.7 miles per hour or 44.6 kilometers per hour.
That's pretty fast.
Yeah, they're some of the, quote, top speeds ever calculated for theropod tracks.
Cool.
And the second trackway showed faster speeds than the first trackway. You could also tell in the footprints when the speeds accelerated or decelerated. And the second trackway shows these abrupt speed changes, which, quote, suggest a maneuvering dinosaur.
Oh, that's cool.
Yeah. Yeah, you can learn a lot from tracks.
Makes me want to go to Spain and check out some dinosaur tracks.
Yeah, what are these maneuvers?
Yeah.
And next up, this was published in Current Biology by Jens Lalensack and others. And it's about sauropod trackways and their gaits or how they walked. So basically, the researchers found a new way to analyze footprints and estimate how sauropods walked. And they looked at the timing and spacing of footfalls of 3 trackways in Arkansas in the U.S., the DeQueen Formation. And these trackways were found back in 1989 and in 2018. Now, past studies found that sauropods had a pace gait like giraffes, where the right legs or the left legs moved at the same time.
Huh, that's weird.
I had to watch some videos of giraffes because I hadn't noticed before, and yes, that is how they move.
It seems like that would make you kind of unstable, moving all one side at a time.
Yes, exactly. So for a sauropod, they had a wide gauge, and there's a risk of falling over. They're so heavy, they couldn't move like that, and if it fell, they would probably die.
Yeah, because in order to do that that's sort of how we walk, right? We do one side at a time, so we only have one leg on each side.
We only our options are more limited.
But in order to do that, we have to shift our weight from side to side as we walk. And the heavier you are, the more awkward that weight
Mhm.
shifting is.
So for sauropods, it seems like, well, they probably should have moved differently from giraffes to increase their stability.
More like a elephant, for example, one might presume.
Well, they do talk about elephants, but they actually found that sauropods walked more like beavers and hedgehogs, where they move say you move the front right and your back left leg at the same time, then you move your front left and your back right leg. It's different from elephants because elephants lift each foot one by one.
Oh, okay. So it's even less.
Yeah, which is I had to watch a few other videos to I guess I don't pay attention to how animals' legs are moving when I'm watching them.
Yeah, that's kind of surprising that they think elephants had to go 1 foot at a time, but sauropods could do 2 feet at a time, just in
Mhm.
that diagonal direction. That's really cool.
Yeah, it's called this diagonal couplet pattern. So it's different from both giraffes and elephants. And what the team did is they measured the distances between each track and they noted if the track was made by a front or back foot or a left or right foot. Then they calculated the time lag between the front and back feet. That's called a limb phase, and that can be used to describe if an animal is trotting or other types of gaits.
Hmm.
And they figured out the gait based on this measurement. So, as an example, a pace gait with a limb phase of 0% would mean that the front and back legs on one side moved together, like both right legs or both left legs moved at the same time. The team tested their method on 15 trackways that were left by modern animals, including 3 dogs, 2 horses, a camel, an elephant, a red fox, and a raccoon, and they found that their approach worked and was pretty accurate. So you could apply this type of analysis to other sauropod and other types of dinosaur tracks.
That's a good point because, yeah, we're saying sauropods walked this way, but there are a lot of different sauropods.
Mhm.
So saying sauropods walk that way is sort of like saying mammals walk away, you know?
Right, and then there's all kinds of different dinosaurs too. They
Yeah.
all walk differently.
But even just within sauropods, there's probably differences. Like they may not have all walked. Like they used to think there were wide gauge and
Mhm.
narrow gauge sauropods. Now we think that might have to do with just sort of what sediment they were walking on and things like that.
Yeah.
But that doesn't mean that maybe there weren't sauropods that walked in different patterns with their feet.
It'd be interesting too if a juvenile sauropod walked differently from an adult sauropod because as they got bigger and heavier, they had to change.
Oh yeah, yeah. If it's more efficient when you're small to do the paired one side at a time versus the
Mhm.
diagonal.
Or if there's any dinosaur that picked up 1 foot at a time like an elephant.
Yeah. Yeah, like an especially heavy sauropod that couldn't handle 2
Mhm.
feet at a time.
Yeah, so pretty cool. And the next one, this was published in Royal Society Open Science by Antonio Bellel and others, and this is about the late Triassic sauropodomorph Thecodontosaurus antiquus and how it walked. So the team reconstructed the limb muscles of Thecodontosaurus, which is an early sauropodomorph, and that helps show how sauropodomorphs transitioned to walk eventually onto 4 legs into the sauropods. Now, Thecodontosaurus walked on 2 legs, and it was small to medium sized. It lived in the late Triassic in what is now Europe, and we covered it as the dinosaur of the day back in episode 214, if you want to check that out. The authors analyzed a collection of Thecodontosaurus specimens from the University of Bristol Geology Department, and there are hundreds of specimens there. Unfortunately, no complete articulated specimen has been found. But a lot of the specimens have scars and rough textures from limb musculature, so that can tell you a lot.
Yeah, that's helpful when you're reconstructing muscles and a model for movement.
Yeah. The team also inferred where muscles attached by looking at living crocodilians and birds, which
Yeah, you
also
kind of have
makes
to.
sense. Yeah.
You can't find the actual muscles preserved. And there's a lot of similarities, even between like humans and dinosaurs. We have a lot of the same muscles. Not all of them, but a lot of them are pretty analogous.
Yeah. So, based on the reconstruction, they found Thecodontosaurus to be agile and that it probably grasped objects with its hands. It didn't use its arms for walking.
Hmm.
But the limb muscles also help show the early stages of sauropods becoming quadrupedal, walking on 4 legs. There were already some key features, such as having a well-developed cuboid fossa, which is located around the elbow, and it may have had flexibility in the elbow, may have been able to extend it. There were also reductions in the pelvis that made it possible for it to be a facultative quadruped, able to walk on four legs when necessary.
Cool. I wonder when it would have been necessary. Ground's getting slippery or something?
Yeah, could be. Or food related. A lot of this seems to be food related.
That's true. Yeah, foraging low or something.
Now, this next one, this was published in the Geological Review by Grzegorz Pienkowski and others. And it's about hundreds of dinosaur fossils and footprints that have been found in a clay mine in Mazovia, Poland. These fossils are from the Jurassic, about 199 million years ago, and this area was a coastal region at the time. And the fossils were found when there was mining going on. Now, so far, there's 60 blocks of rocks with several hundred fossils found, carnivores and sauropodomorphs. And that includes some skin and claws and footprints. It's possible that there are thousands more fossils here too. So the plan is to excavate more than 200 blocks of rock, which I imagine will take a long time.
That's cool that they found footprints and fossils down there.
Yeah. Oh, it'd be great if you could pair the footprints with the fossils and know what exactly made that track.
Yeah, because a lot of times you don't find fossils of limb bones or of any kind of bones and fossils of tracks in the same place. So you have, tracks on one side of the state or something, and you have the bones on the other side of the state, and you don't know which ones go together. But finding them in the same place is awesome.
Yeah. And these fossils, they're well preserved, and the tracks and other ichnofossils show dinosaurs that were running, swimming, resting, and sitting on a muddy sediment. So a lot of different behaviors there to learn from.
But that's even cooler than the ones in Spain, I think. I mean, the ones in Spain might be faster, but the ones in Poland have more diverse behaviors.
And there's a lot of places we want to go, and there's a lot of cool trackways around the world.
I wonder if these are in like an open pit mine. I kind of assume so if they're mining clay. I don't think that's the kind of thing that you follow a seam down into the earth to get, because clay isn't valuable enough probably to do that. But I was thinking it could be cool if it's underground, it might be preserved better. But I guess it depends on where exactly the mine is and how it's located.
It's hard to say.
Yeah, that's cool. Now I've got one last dinosaur track paper to talk about, and it's the update on the Mill Canyon Dinosaur Track site. Brent Breithopt from the Bureau of Land Management released a report on those damaged dinosaur tracks from north of Moab, Utah. And that Mill Canyon Dinosaur Track site is also known as MCDT. It was first reported in 2009, and the tracks are dated to the Early Cretaceous, about 112 million years ago. They include over 200 tracks that cover about 2.3 acres, which are fenced in, and then they have a boardwalk around a smaller section of it. But among those tracks are non-avian theropods, sauropods, ornithopods, ankylosaurs, birds, and crocodiles, including a crocodile slide mark.
Another cool trackway site.
It is. It's really cool. The tracks are in mudstone, which about 112 million years ago was along the shore of a shallow lake and probably covered in algae. But now it's basically in the desert. And being in mudstone, too, it's not necessarily the most stable, so it is a little bit fragile, and you got to be careful around it. The author says it ranks as one of the top 10 dinosaur trackways in the U.S. They might be a little bit biased because, it's one of their track sites that they oversee.
But having over 200 tracks is impressive.
It is really cool, yeah. Fortunately, it is also one of the most well-documented track sites in the U.S., including multiple rounds of photogrammetry that have been done since its discovery pretty recently. So the report confirmed that the track site was damaged in 2022 in January while working on replacing the boardwalk near the tracks. The walkway, actually, that boardwalk walkway, only gives access to about 0.15 acres, or in other words, about 6,500 square feet, or about 600 square meters of the trackway. And they call that area around the boardwalk the interpretive area.
Oh, interesting.
because, it has signs and some information about what's going on there.
But it's a small area that was impacted.
Well, yes and no. So that's the area that they were focused on. That's about 10% of it, which doesn't have anything covering it and has the information about it, and it's easy to access. The work wasn't done completely out of nowhere, like some people on Twitter were saying when it got damaged. They did do an environmental assessment in 2021 before deciding to replace the boardwalk, and they did avoid damaging the tracks inside the boardwalk in the interpretive area,
Oh, good.
although a couple tracks were damaged, most likely by weathering and people walking on them.
Hmm.
Because the best thing they could do for this article was compare pre-photogrammetry information to the current. And it's not always clear whether or not the track was damaged by somebody stepping on it, by the weather, or if it was a track or an errant board being dropped on it or something. The author did highlight the need for the walkway, saying it discouraged people from walking directly on the tracks intentionally or accidentally,
That makes sense.
because it does look like a couple of the tracks were probably damaged by someone either like stepping off the boardwalk accidentally or intentionally or whatever. But the boardwalk is important, and they did say that it did need to be replaced. It wasn't in as good of condition as some people on Twitter, again, were saying that, like, why were they even replacing this? It's fine. It apparently isn't really fine, and you want it to be in very good shape so that people stick to it and
Yeah.
don't go off on their own. However, the environmental assessment was, quote, not reviewed by qualified paleontologists and were not well distributed for public comment,
I
end
think
quote.
that's what most of the outrage was that we saw.
Yes. And it did result in some very bad planning. Specifically, they okayed driving in areas that include lots of tracks, which should have been flagged for avoidance.
Oh,
So there is that 10% of the area that's inside the boardwalk. And it looks like they did a really good job about avoiding those because they're really obvious. And, that was sort of the point of the boardwalk, to be around that area. But there's that other 90% outside the boardwalk, which a lot of it was designated for driving on to get to the boardwalk.
mm-hmm.
So they're basically driving over the tracks in order to get to the boardwalk around other tracks. That was really the big problem. There were also other areas which weren't specifically cleared for vehicle traffic that were driven on as well because they weren't well marked.
Ooh, yeah.
Some of those tracks were also damaged, although less so than the ones which were intentionally driven on.
That makes sense.
And the pictures make it really obvious why that mistake would be made. The tracks inside the boardwalk are really easily visible. They don't have anything covering them. They look just like you'd expect a dinosaur track to look, a footprint clearly visible in rock and nothing on top of it. But the tracks outside the boardwalk are almost all covered in dirt and little plants and things like that. So there's no way you'd ever know they were there unless you asked a paleontologist or someone who is really familiar with the area.
Mm-hmm.
So basically, they were just driving on dirt from what they understood to
Right.
get to this boardwalk, which was around clearly visible tracks.
So they thought it was a safe spot to drive.
Yeah, and they did their assessment in advance. And when they said, okay, we're going to drive around from this side of the quarry or from the track site, and we're going to put the vehicles here, and then we'll remove the boards this way, and we're going to do all that. And they planned it all out, avoiding the tracks that they knew were there, but they didn't realize that the other 90% of the tracks were hidden under a thin layer of sediment around it. And unfortunately, the dirt around it wasn't thick enough to really protect the tracks. And so when you're driving a backhoe or a truck or something on top of it, it can damage the track underneath that dirt. On the bright side, though, despite all the driving on the tracks, quote, overall, damage to the tracks and traces as a result of the impacts from construction activities appears minor, end quote.
Good.
They do caution that driving on the tracks probably caused small cracks, which will accelerate degradation from weathering. So it's not as simple as, they're all fine now and they're going to stay fine.
Mm-hmm.
They might not be fine, but they have a lot of the tracks have been weathering in the meantime because they're in mudstone exposed to all the elements. In fact, they're basically at a riverbed. So water goes over the top of them pretty frequently and damages them. So it's really about allowing people to appreciate these as they slowly erode away. And then we're also documenting them in the process, which is partly why we have so much good photogrammetry of it, because we know it's not going to last forever.
Mm-hmm.
They also produced a list of 20 recommendations to prevent future damage and better preserve the site. One of those recommendations is to clear off the tracks so more people can enjoy them. And presumably, they'd also be more visible to future construction crews, too.
Yeah.
If you were on that boardwalk and you saw, oh, there's also tracks outside the boardwalk, not just inside the boardwalk.
That's a trade-off because then they're more exposed for weathering,
Yes.
but on the other hand, people know to stay off them.
Yeah, but I mean, they're going to weather either way because the water goes through the dirt.
Mhm.
You're right that they're more protected with the dirt on top, but you might as well enjoy them
Yeah.
while they're there and possibly even build more boardwalk around the area so people can see all of the tracks. So at the end of the day, the Twitter outrage machine did do a good job of stopping the work shortly after it started so that not too much damage was done. I didn't really get into the whole timeline of events. It's
Mhm.
all spelled out in the paper of they started work on January this day, and then by this day people were screaming about it, and 3 days later the BLM halted the work, which is good
Mhm.
that they did that. But it's not like people were driving all over exposed tracks. That was sort of my interpretation, like people just recklessly driving on tracks which were clearly visible. That wasn't the case. Almost all of the exposed tracks were completely avoided. But there were lessons learned, and fortunately, not much was damaged.
Good. And then moving forward, when there needs to be maintenance, then we'll have a different plan.
Yep. And hopefully, this means that other track sites around the world, because this was such big news, people are aware of this kind of thing and the fact that just because you can't see the tracks right there doesn't mean
Mhm.
there isn't something under the dirt right next to it that you might want to be careful of.
True. And that's hard to keep in mind when you can't see it.
It really is. Yeah, the picture when you look at the pictures, they're like, yeah, why would they avoid that area? It's just
Mhm.
dirt with like little shrubbery on it.
We also have some museum and exhibit news. I'll start with the Natural History Museum in London. They're looking for a partner to display Dippy the Diplodocus. Dippy, we've talked about Dippy a number of times on this show, and Dippy did really well on the tour around the UK, and the museum wants to keep that going. They're looking for a long-term host. Dippy will be available for this host starting in 2023, next year. They said you don't need to be a museum to host, you just need to have an indoor space large enough for Dippy and have space for visitors to engage with the dinosaur. And they're taking applications now. The deadline's July 15th. So that'll be really interesting.
Saying you just need a space large enough for Dippy
Yeah,
is
I
like
mean, the Dippy is large.
an, an indoor space for a sauropod.
Yes. But the fact that it doesn't have to be a museum does open up other
Oh, yeah.
venues.
Yeah, because there's like churches, there's malls, there's all sorts of large indoor areas. That's
Mhm.
true. Or even like a airport.
Oh, yeah. Yeah, that'd be easy to visit. In the US, the Children's Museum of Indianapolis has a new Dinosphere Show. It includes 2 new sauropods on display. Those fossils from the sauropods were found in Wyoming in the Jurassic Mile, and they show one sauropod on 4 legs and one sauropod rearing up. It could be that these sauropods are a new diplodocid species. Now, they think that the specimen that they ended up displaying on all fours died in a flood, and the specimen that they are displaying as rearing may have died in a ponded area. A lot of theropod teeth were found near the rearing sauropod specimen, so it could be because the sauropod was a large meal, and then a couple theropods could eat it without fighting over it, or the sauropod was there for a long time, or the theropod teeth were washed there from other areas. The Children's Museum of Indianapolis has a 20-year lease on the Jurassic Mile, and their Dinosphere has other dinosaurs on display, including the Hipparchosaurus. There's also T Rex, Triceratops, aquatic animals, an art lab, and a paleo lab where you can see fossils being prepared.
Nice.
And one of these days, we'll have to make it to that museum.
Yeah, that sounds like a pretty solid set of dinosaur exhibits.
Mm-hmm. In Oakdale, Connecticut, the Dinosaur Place at Nature's Art Village opened for the season on April 1st, and the theme this year is Big Season. And this place, it's a 60-acre outdoor adventure park with more than 50 life-size dinosaurs. They also have a dinosaur-themed maze, a T-Rex tower, and 2 dinosaur caves. So sounds like a pretty fun place to go.
Dinosaur caves.
Yeah.
That's intriguing.
I've also got a quick update on the Dinosaur Kingdom Park in New Jersey. It's now going to be on 131 acres of land in Monroe. Originally, they were thinking of putting it in Wallkill, but Wallkill had a zoning obstacle, so it's taken more than a year of review, and now it's going to Monroe. The park will cost about $12 million to create, and the plan is to have over 60 life-sized animatronic dinosaurs, playgrounds, and other rides and attractions. They'll be leasing the land, and Monroe, the town's planning board, still needs to review the project plans, but they're hoping to finish construction in 2023, which is pretty quick.
That's very ambitious for plans that haven't been approved yet.
Yeah. It sounds like they're excited, so maybe it'll be approved quickly. In Livingston, Scotland, the center, it's a shopping center, has a new exhibit, Brickosaurus Trail. That's around 500,000 toy bricks that look like Legos. They had 20 designers create them over 3,000 hours to build and glue all of these dinosaurs together. It includes a Parasaurolophus, which took 100,000 bricks, and Velociraptor, which took 45,000 bricks. There's a trail hunt. You can follow a map to find all the dinosaurs around the shopping center and learn facts about all the dinosaurs. And this trail is open from now until April 18th. And our last item is that apparently Nicolas Cage hasn't been refunded for the Tarbosaurus skull that he bought at auction that got repatriated to Mongolia. He bought the skull back in 2007 for $276,000 US. He didn't know it had been illegally taken to the US. And then the Department of Homeland Security told him in 2014 that it may have been taken illegally, so he had to give it back, which we talked about on this show.
Yeah, it is a really weird loophole to me that it seems, I could be wrong about this, but from my understanding, if you're auctioning something off as an auction house, it comes with a caveat that basically this might be stolen and we don't guarantee that it's not stolen. And if it's stolen, that's just too bad for you,
Yeah.
but we're not going to give you the money back, which seems insane.
Yeah. I don't think he's happy that he hasn't been refunded.
You should definitely get refunded. It seems like that should be the point of the big fees that auction houses get, figuring out where they came from. And if you can't validate that it's not stolen, then you shouldn't be auctioning it off. But I don't know. Maybe I don't understand how auctioning works.
I don't know much about that world. Well, we know a little bit now through dinosaurs, but still not much.
Yeah. And now we're going to take a quick sponsor break, but when we get back, we'll be on to our interview with Thomas Halliday. And now on to our interview with Thomas Halliday. But of course, as always, we have an extended version of this interview. So if you're a patron, make sure to check out your premium content feed and listen to the extended interview there. So we are joined this week by Thomas Halliday, who is a paleobiologist who specializes in mammal evolution and phylogenetics. His research also includes Renaissance paleontology, faunal networks, and decolonizing paleontology. And he's the author of the book, Other Lands, A World in the Making. And that's why we're talking to him today. Thank you very much for joining us.
Thank you for having me.
So we really enjoyed the book. It's about Earth as it used to be, how it's changed, how life has adapted or not. There are a lot of really great illustrations. I liked that it goes back in time and you've got these chapter titles like Emergence, Foundation, Rebirth, Origins, Thaw. What was the inspiration for your book?
Really, I think there are a couple of inspirations. So firstly, it's the sort of preponderance of dinosaur and ice age books means that there's a lot of Earth history that sort of goes unrecorded as far as the public communication of paleontology goes. Right. So, we're very familiar with, saber-toothed cats and woolly mammoths, and we're very familiar with, a sort of condensed all-in-one idea of dinosaur times where, everything from Triassic to Cretaceous is sort of blurred into this homogeneous zone.
Yeah.
But people tend not to really know very much about, for example, Ordovician seas or Cenozoic mammals, more recent things. So it's partly an attempt to counter that, but also partly just trying to express it as these creatures are not just skeletons that are found in museums and just single individuals. They were part of a thriving ecosystem, and so it's trying to take this ecological approach back through the fossil record.
Cool. Yeah. So we love the close looks at, say, one specific ecosystem where they talk about everything that goes on. Is that what paleobiology is in general, looking at sort of everything and how it's connected?
Yeah, we talk about the paleobiological revolution that happened over, I guess, about the sort of 70s or 80s. It was really that point where paleontology, the study of ancient form, moved into paleobiology, the study of ancient life. So it sort of turned from the classic example of, old sciences, physics or stamp collecting. Paleontology was sort of the classic stamp collecting, amassing a huge amount of specimens and naming them and classifying them and so on, into actually studying living organisms and treating it really as an aspect of biology. It's just about things that aren't around anymore. And so, yeah, what the book does is it takes 16 of these sites from across the last 550 million years of Earth history and looks in detail at the animals and plants and fungi that were living in a very specific defined place and the aspects of that place that sort of give it a sense of place, the climate, the topology, as much as we know these things.
Awesome. Yeah, we always like to emphasize that detail, like the one really famous expression where you say we're closer in time to T-Rex than T-Rex is to Stegosaurus. And Stegosaurus isn't even really all that early in terms of dinosaurs.
Sure.
Was it difficult to narrow down the sites to focus on, especially after an extinction event?
I think some of the sites were an absolute shoe-in for this. So I'm a researcher of Paleocene mammals, as you sort of said in my introduction. And so the site that I chose for the Paleocene epoch, which is the period immediately after the last mass extinction event, is part of the Hell Creek Formation. The Hell Creek is really well known as a Cretaceous site. T-Rex is there and other famous dinosaur fossils. But it also includes the boundary itself, the iridium layer that's the signature of the meteorite's blow and the fern spike that immediately follows. And in that, just above that fern spike, what we find is the earliest communities of Paleocene placental mammals. They're the earliest definitive placental mammals in the fossil record. And so sort of understanding what's going on there was always important. And I also wanted to definitely include, at the end of the Miocene epoch, what's known as the Messinian salinity crisis, which is when the Mediterranean got separated from the Atlantic and became this kilometers deep salt pan. It evaporated entirely before being refilled in this catastrophic flood event known as the Zanclean flood. Other periods, like the Jurassic, were almost impossible to decide because there are so many really interesting and well-preserved ecosystems out there. So what I was trying to do was to make sure that every continent, every modern continent, had some representation, and also that it was a bit more varied, because if I was just picking the best preserved ecosystem over time, you just have shallow lagoon after shallow lagoon after shallow lagoon, right? Not so interesting to sort of write about. Each place sort of remarkable in itself, but after a while getting a bit samey.
Do have to ask about the dinosaurs.
Of course. Yeah, well, yes, I feel like if I didn't talk about dinosaurs on your podcast, it would probably be a betrayal of your listeners.
I thought it was really interesting, all of the dinosaurs that you talked about that have been found in China with the thin feathers that are for display or distraction to aid in escaping predators. I hadn't thought about the distraction part before. I guess, could you tell us a little bit, how could feathers be a distraction aid?
Well, I think what you're talking about there are the Confuciusornis when it comes to the thin feathers. So these Confuciusornis is a flying dinosaur. It's one of these, what are known as eoantiornithines, which is an appalling word to say. And it means dawn opposite birds, because they're not actually birds, they're just close relatives of birds, and the very early ones at that. So many of these specimens have these two trailing streamer-like feathers that come out of the back, so tail feathers essentially. But they're unlike any feathers of modern birds today. That from specimens preserved in amber, we can see that they're extraordinarily thin and relatively stiff in the way that they're held out, because they have this cross-section that is a bit curved, I guess like a tape measure. right?
Mhm.
That if you extend a tape measure out, you can hold it up for a while before it finally collapses. It has that sort of stability. And so you've got these thin feathers that have that kind of cross-section. But as to how feathers can be, a distraction, it's another part of the body that if a predator tries to bite onto it, it's just going to come away in their mouth. So it becomes this, alternative way of getting away. It's not just the speed, it's just having parts of your body that you can lose, in the same way that several species of lizard will drop their tail
Was just about
if
to
they are
ask,
caught
yeah.
by the tail. Yeah. Except, losing a feather is a considerably less bloody and protracted process of regrowth. And what's interesting really about Confucius and other Toronto things is that not every member of the species has these. So there are questions about whether is it only the males that have them, and it's inferred to be males just because in modern birds they tend to be a bit more showy and have the sort of showy display structures, or is it because they are regularly lost? And I mean, with the example of the feather that's preserved in amber, I mean, it presumably just got stuck in the amber and was pulled out by being attached to a sticky substance.
Oh, interesting.
Yeah, so you wouldn't expect it to be like on a quill knob or something really deep in the attached to the bone, because that would be quite an extraction there.
Yeah. There was also a mention of Utyrannus and how its vocalization evolved independently from crocodiles and birds, and it had this throat swelling and falling back with a rumble. Do we know what Utyrannus would have sounded like? I think I'm mostly familiar with it, talking about Parasaurolophus, but other dinosaurs.
Sure, there are. Specifically with Utyrannus, no. So when I'm talking about that, that's in a more sort of general dinosaurian way. So dinosaurs they don't have a larynx like we do. They have a syrinx like birds, and the syrinx is capable of a sort of different set of vocalizations. The syrinx is actually an extremely recent radiation, an extremely recent diversification. And most birds, sort of early birds, have this sort of very basic call. If you think about ratites and ostriches and cassowaries and emus, they've really quite a sort of bizarre, almost grunting roar of a call. Not a mammalian guttural roar, because that's something which is rather specific to our vocal apparatus, but yeah, this sort of low sonorous noise. And crocodiles and alligators are the same, and they do this by their throat swelling up and then pushing it back. So essentially what I'm doing there is taking what we call extant phylogenetic bracketing, which is taking the two most closest relatives of the extinct organism and inferring back from there. Parasaurolophus is, of course, a really interesting dinosaur because of its really long nasal passage that is all convoluted up in that crest that extends from the back of its head, and has been argued to sort of function like a trombone, I guess, like a brass instrument. And it certainly could have done. There have been people who, and I'm sure you may have had them on your podcast, have done sort of reconstructions of how air would have flowed through that structure. So yeah, of course, we can expect that dinosaurs would have had a variety of vocal noises, but the typical ones of, the roaring T-Rex was something that I just wanted to dispel a bit, because birds and crocodiles, when they make these roaring noises, these deep, low roaring noises, they don't open their mouths, right? They make these noises with closed mouths, right? And so the image of the sort of T-Rex that just sort of stands there and angrily roars at you before charging and attacking it is really based on an idea of what mammalian predators do today, right? It's what the filmmakers and other creative people who are just not so familiar with dinosaur anatomy have done this. They've done what they know, and of course they've done what they know, and that's completely understandable.
So there was another really interesting tidbit I hadn't thought about before. Cotopteryx, you talked about their communal nests and how their eggs, like the females, they lay these blue-green eggs that show she's this healthy, successful feeder. So the brighter eggs make the father more likely to be more caring towards his offspring. I thought that was fascinating. Like, is this another example? We're kind of looking at modern animals and seeing what they do and extrapolating from there?
Partly, but there's good evidence behind it as well. So for the color, there's been a lot of work actually been done by a scientist called Jasmina Weeman, who has been looking at the pigments of dinosaur eggs and how those have evolved. And so we are pretty certain that oviraptorosaurs, of which Quadripteryx is one, had blue-green eggs. When you get that kind of bright colors, those kind of bright colors in modern day birds, that is often a signal to whichever parent is looking after it. And the reason that we suspect that this is a communal nest is because you can do some chemical analyses of eggshells and discover that the eggs in different layers show isotopic signatures that say that they were laid by different mothers. So there's kind of like a fingerprint of multiple females laying eggs in the same nest. And so in modern birds, the best analog for that is probably what happens in ostriches. So for ostriches, you have a single male that sort of builds and guards a nest. And then females will come along and they sort of compete for the male's attention as well. And whichever female is sort of the dominant female of the group ends up with the eggs in the best position, sort of in the center of the nest. And then other females will then come and lay their eggs on top. And these are earth nests as well, so very similar to the ones that we expect oviraptorosaurs to have built, where they're essentially burying their eggs and then brooding them. And then in ostriches, what happens is that the dominant female ends up brooding the nest, but there's a substantial amount of paternal care after they've hatched. So obviously that's something that could only ever be speculation for non-avian dinosaurs, but there have been a few studies which look at the size of clutches, so number of eggs and the relative size of eggs, which suggests that many dinosaurs, including oviraptorosaurs, practiced probably at least biparental care. And I think in some species, I'm right in saying that there is demographic evidence of paternal care. So, when we're thinking about what dinosaurs did in the past as sort of mating strategies and mating behaviors, there's a fair amount that can be inferred from life history and from comparisons with modern animals and from demography and life history traits, and a surprising amount that you can also get from even the chemistry of the egg cells.
Cool.
That's really cool. So specifically about the color, some modern birds do have pretty brightly colored eggs as well, right?
They do, yes.
And then are any of those parental care? Is that how you're like kind of combining those pieces?
Yes. Yeah. So it has been shown that you get better care. So from birds where there are multiple partners and different eggs, the egg color is one of those sexually selected traits, where partners who can produce the pigments, so mothers that can produce the pigments that create a brightly colored egg, get more input in the rearing of the offspring from the father. But there are other reasons that you might have, brightly colored eggs. It might be to try and avoid mimicry from birds that would then have to expend all that energy creating the pigment themselves to mimic an egg, brood parasites like cuckoos or cowbirds. So that, it's not the only reason that you can imagine that an egg would be brightly colored, but it is a very plausible reason given what else we know about Quadripteryx as a dinosaur and oviraptorosaurs. I mean, a lot of this evidence doesn't come specifically from that genus. It comes from other oviraptorosaurs. And in order to paint a consistent picture and sort of give this information, I condense some of that information to a single genus, because once you start humming and hawing all the time in something that is meant to be immersive and experiential, you then lose a lot of the detail. It can get very confusing.
Yeah, that makes sense. So moving on to this one's more dinosaur related. You're going to have to help me with the pronunciation on this one. Repenomamus?
Yeah, Repenomamus, yeah.
Okay, cool. That's that. You described it as a badger-sized carnivorous mammal, the largest in the Cretaceous world, known to catch and kill baby dinosaurs.
Yes.
We need to know more.
Yes. Yes, tell us more. Well, yes, Repenomamus I mean, the evidence for this is really quite compelling. Repenomammus has been found with baby, I think it's Psittacosaurus, in its stomach contents. So, yes, it absolutely ate hatchling dinosaurs. During the Cretaceous, it's often sort of thought to be that mammals are essentially trampled underfoot of the domineering reptiles and so on. And while ecologically they certainly weren't the biggest organisms, I mean, we're talking, when I say badger-sized, I'm thinking of the European badger. I'm not sure how that compares with the American badger. I think it's a bit bigger, the European one. But it's true that most mammals by then were small, but they weren't really that ecologically limited. I mean, you had things like Castracorda, which is this beaver-like mammal that was semi-aquatic. You had gliding mammals. You had squirrel-like animals that were crawling around in the trees, and you had rodent-like multituberculates and so on. They were small and they occupied small animal niches, but they were really quite diverse as well. And Repenomammus is just one of these which appears to have evolved into a carnivorous niche. And it's a rare example, but it's there. But there's lots of evidence that mammals, at an important early part of their history, ended up being confined to nocturnality. So living at night, and in this case, I guess, hunting at night, perhaps. And we as mammals are very bad at seeing. Vision is our dominant sense, and we are unusual in mammals in having three different color sensors in our eyes. So we can sense red and blue and green, or rather, you can. I'm red-green colorblind, so I have the sort of ancestral condition of mammals of having blue and which one of mine is non-functional? I think I've got the red one, but and then the green one is shifted so that its sensitivity overlaps so considerably with the red that you get this sort of interference. But most mammals only have two cones, whereas birds have four. So what this is sort of evidence of is a movement into a world where color wasn't quite so important, and where you get this sort of rod-dominated eyes, which are just good at detecting whatever photons are out there, which implies that they are living in the dark. So we have this sort of evolutionary legacy as mammals of a sort of ancestral journey where we just were nocturnal for a while in our evolutionary history. And I think it's these kinds of legacies that still have impacts today. The fact that I am red-green colorblind because my ancestors 100 million years ago were nocturnal, in one sense, it's just a sort of wonderful thing to be able to say.
Yeah.
It's almost like you're still living with the dinosaurs a little bit.
I guess. Sort of ish.
Not really.
So we are though, aren't we? We are now the large ones, and
That's true.
And they are now the smaller ones. It's a role reversal, but we're all still here.
That's true.
They're the ones biding their time now.
And then I really liked this quote that you have at the end of the book. It says, "It is by looking at the past that paleobiologists, ecologists, and climate scientists can address the uncertainty about the near and long-term future of our planet, casting backwards to predict possible futures." And that seems to kind of sum up well, because we've at this point in the book, you've gone over all the different kind of places and time periods and everything. It's just, it's, I think, good to keep that in mind.
Yeah, it encapsulates the importance of your work for sure.
Yeah, I think it's really, I mean, if anything is the sort of the take-home message of the book. It's kind of like, okay, so we've had some fun looking at all of these extinct animals, but what actually does that mean, and what can we learn from it? These ecological rules are, while biology doesn't really have fixed laws in the same way that physics does, we see the same patterns emerge time and time again. And that means that the past can be this laboratory setting for what happens when the carbon dioxide concentration in the atmosphere is 10 times what it is today, or what happens when you suddenly get huge disturbances and perturbations to global systems. And we can use those studies to apply to what's coming next and say, well, okay, if we do this, then we expect the Earth system to respond in such a way. I think it's very important. I mean, obviously now in this sort of time when politically I think we are hopefully, at least in this country, building a momentum towards changing our practices, because it's very clear that the last times that we've had greenhouse gases increasing at the rate they are today, then we've had huge turnovers, huge changes. Although the rules of life is persistent as a whole, but individual ecosystems are very fragile. The largest ecosystem 20,000 years ago was the Mammoth Steppe, and stretched all the way across northern Eurasia from Ireland to eastern Russia and also into Alaska and Canada. And it's now restricted to a few patches in Mongolia. And that is what happens when, in that time, we're coming out of a natural sort of change in glaciation frequencies. But, based on where we are in that cycle, we should be about to go back into the cooling part of the glaciation cycle, and we are not. We are very much accelerating out of it. So yeah, the world that we have today, that we live in, is the world that we evolved in, and the world that evolved alongside us, and we are very tied into a huge number of ecosystems worldwide. If you allow things to change too fast and too far, then it seems a shame to throw our world away.
Yeah, definitely. I often hear that sort of claim that, well, the earth changes all the time and that's totally natural. And why would we try to fight it? Or why would we care that we're changing it? And the answer is, well, the earth will be fine. Life will be around. Nobody's questioning that. It's just maybe not human life, maybe not the food that humans like to eat, maybe not the fish that humans like to eat and all that kind of stuff.
But also there's I think an important response to that is, who told you? Who told you that the earth has changed in the past, the climate has changed in the past? It's paleoclimatologists.
Yeah.
And it's the paleoclimatologists that are telling you that the change that is happening now is fundamentally different and faster and more devastating. So yes, it's a very silly response. It's a sort of fatalism, I think, that people tend to go into. It's kind of, this system is too big for us to really influence, and we're just going to have to live with whatever happens, right? Which I think, and that is practically as bad as climate denial and saying that nothing's changing.
Yeah.
What we really need to go on is to move away from this passivist approach and make sure that we are all being activists in this.
Yeah, definitely.
For our listeners, where's the best place to find out more about you and your work? Probably online.
Yeah, online. I do have a website, thomashalliday.co.uk. I am on Twitter at TJD Halliday, and that's probably the best place to get news. Otherwise, just online in general, I suppose.
Of course, they can pick up your book, Other Lands: A World in the Making.
Yes, absolutely. That's that. Yes. So, Other Lands: A World in the Making is the UK subtitle. In the US, it's Journey Through Earth's Extinct Worlds. But yes, Other Lands.
That's the key word, Other Lands. We'll have a link in our show notes.
Other Lands, all one word. Click on the link.
Awesome.
Excellent.
Well, thank you so much for joining us.
Thank you.
Thanks again, Thomas, for the interview. And again, for anyone looking to learn about and read about different animals on different continents throughout time, then check out his book, Other Lands.
And we'll get on to our dinosaur of the day, Adeo Papasaurus, in just a moment. But first, one more quick sponsor break.
And now on to our dinosaur of the day, Adeo Papasaurus, which was a request from Crow via our Patreon and Discord. So thanks. It was a sauropodomorph. I'm getting a lot of sauropodomorphs and sauropods in this episode. And it lived in the early Jurassic in what is now San Juan, Argentina, found in the Cañon del Colorado Formation. It looks like other sauropodomorphs with a long neck, a small head, a long tail, and walked on two legs. It's estimated to be about 10 feet or 3 meters long. It was an herbivore, and it probably had a keratinous beak.
Don't usually think about beaks with sauropodomorphs.
No, it's one of the first known to have a lower and upper bill. Now, the lower jaw was about 10% shorter than the upper jaw, and that gave it a slight overbite. The type species is Adeo Papasaurus magnai. It was named in 2009 by Ricardo Martinez, and the genus name means far-eating lizard, and it refers to its long neck.
It eats far away from its body, I guess.
The species name refers to the Mogna locality in San Juan province where the fossils were found. The holotype includes a skull, vertebrae, pelvic girdle, forelimbs, and incomplete hind limbs, and it's known from 4 partial skeletons and 2 partial skulls. It's pretty similar to Massospondylus, and actually it was first thought to be Massospondylus. It had a gracile femur and short forelimbs, and a gracile and delicate humerus.
So, like a lot of early sauropodomorphs, it's pretty skinny.
Mm-hmm. Skinny with a slight overbite.
And our fun fact of the day is that dinosaurs get through early development remarkably faster than humans do.
Oh.
And by early development, I basically mean from the fertilization of an egg to hatching and being able to do anything, or being born in the case of humans.
I guess it kind of had to, or they kind of had to.
Well, not necessarily, because, well, I'll just get into it. So, for an extreme example, chickens hatch after 21 days, or about 3 weeks. Chickens are dinosaurs.
Mm-hmm.
But it does take about a week after mating to develop the embryo, form the shell, and lay the egg. So, all told, it's a little bit more like a month of total gestation. It's not really fair to compare incubation time to total gestation of a mammal.
Still fast.
Yeah, so about a month. For mammals, prairie dogs are about the same size as a chicken, and their gestation time is also about a month. Chickens, however, are more precocial, aka independent, than prairie dog pups. Not surprisingly, since, mammals have to drink milk.
Mm-hmm.
Nonetheless, though, it's definitely possible for mammals to give birth quickly to young and have them out in the world in about a month. Not all birds reproduce as fast as chickens. For example, the kiwi lays a huge egg, about 25% the size of its body. Typically, birds lay eggs closer to 4% their body mass. And as the Audubon put it, I think I used this in an earlier fun fact, quote, proportionally, this is by far the largest of any bird in the world. Imagine a chicken laying a 1-pound egg, or more graphically, a human giving birth to a fully formed 4-year-old.
Oh, no thank you.
It's large.
Poor kiwis.
That's a lot. That's a lot to give birth to. It takes a kiwi egg about 80 days to hatch, but it further takes the kiwi about a month to develop inside the mother because it's so big and it's got a thick shell and all that jazz. So nearly 4 months of total gestation for an animal about the size of a chicken. So it's not just about the size of the animal. The biggest advantage seems to be that with a kiwi egg, it has a much higher fat content with 65% yolk. Normal is more like 35%. And because of that, the kiwi can go 2.5 weeks without food after it hatches.
Wow.
The yolk basically ends up in its stomach, more or less. And that huge egg means that they come out larger and stronger, so they're less likely to become prey after hatching. And they don't have to worry about food right away, which is pretty great. And since New Zealand didn't have many predators for eggs until humans introduced things like mice,
they were safe.
Yeah, it might have been the best possible evolutionary advantage to have these huge eggs. And the gestation time probably wasn't a big selective pressure. Humans are a completely different story. The short answer to why we have such a long gestation is because we have big old brains that take a long time to grow and a lot of energy to grow. And then we also need a body to support that big head.
Although it takes a while to fully support the head.
It does. When we're born, we don't really have enough body to support our huge heads. There's also a linear relationship between brain size and how long it takes to walk, which predicts that humans would take almost as long as an elephant to walk. And that is about how long it takes us to walk. Unfortunately, the 2009 study in PNAS that I got that from didn't include birds in their relationship study, so I can't see exactly where they fit. And I think it didn't include birds because our brains have a pretty different structure to bird brains. They have more dense neurons and details like that, so the relationship probably isn't 1-to-1. Interestingly, I had no idea about this. There has long been a consensus that humans are actually born too soon.
Oh. Wow.
Humans under 1 year old are very vulnerable to all sorts of things. Our lungs aren't particularly great when we're
Mhm.
under 1 year old. Our immune system isn't that great. We can't hold up our heads. We can't walk. We have lots of issues under 1 year old. And I found several sources, peer reviewed sources, saying human gestation should last about 21 months ideally.
Also, no thank you.
But if our gestation did last that long, our babies would be better at breathing, able to walk, overall just way more ready for life than our babies actually are.
But how do they come out if they're so much bigger?
Yes, so for a long time, the hypothesis was that human gestation was limited by our narrow hips and our big heads, which is often called the obstetrical dilemma. The claim is basically that we needed narrow hips to walk upright, but the narrow hips didn't leave room for a large brained body to be born. So basically, we gave birth to premature babies because that was the best we could do. We needed to walk upright. That was the solution. However, a study in PNAS in 2012 found that we're actually limited by our metabolisms. Basically, fetal energy demands increase exponentially, and pregnant humans can supply about 600 kilocalories, or 600 calories in nutrition terms, of additional energy to their fetuses. But by the time the fetus reaches about 9 months old, the fetus needs all 600 kilocalories per day that the parent can provide, and the energy requirements are still rapidly increasing because it's exponential. So if you went to 10, 11, 12 months, all of a sudden the parent can't supply enough energy to keep up, and they either have to lose a bunch of nutrients from their own body, which is what some animals do. They basically die off in the process of giving birth, or you give birth early.
Hmm.
So it seems like that's why humans give birth at 9 months.
That explains why I'm getting hungrier and hungrier.
Yeah. And why at the end of the third trimester, it's hard to do much of anything because so much of your energy is being sapped. And that's because, again, our babies have huge brains, which are really energy intensive, even just living. So it's difficult to support. Backing this up was a PLOS One study from 2015 showing that wider hips aren't less efficient for walking. So the old bipedal narrow hips versus baby big brain comparison doesn't hold up to scrutiny because there's no reason we couldn't have just evolved wider hips. We would walk upright just fine with slightly wider hips and a larger opening for a baby head. The thing is, we don't need a larger opening for a baby head because you can't have a baby inside you any longer anyway, because you can't metabolically provide nutrients for it without, having big problems. I was hoping to find some connection between dinosaur genes or egg laying advantages to quick hatching, but nature is never that simple. The simplest answer seems to be that our big brains are the limiting factor on our long gestation. And I put long in air quotes there because apparently our gestation is actually way too short.
Right. Should be as long as an elephant's.
Yeah, I don't think any pregnant women feel like our gestation is too short. But I guess if you look at it in terms of what the baby's like, should take longer. As a quick reminder, viviparity, giving birth to live young, has evolved over 100 times, but it hasn't been documented with any birds. However, several other reptiles do give birth to live young. For example, the small lizard Zootoca vivipara. It's got vivipara right in the name.
Mm-hmm. So you know what it means.
Yep. Its common name is the viviparous lizard, but weirdly, some populations of the viviparous lizard lay eggs and others give live birth.
That's confusing.
It's so weird, and it shows you just how close these things are. There's also a different kind of, I think it's oviviparous, which is basically having eggs inside the body. Some sharks and other animals do that. So you can have an egg outside the body, an egg inside the body, or you can have a womb like we have, and you can go back and forth. There are actually cases they think of animals going from laying eggs to live birth and then back to laying eggs, which might be the case with the viviparous lizard, for example. So all that is to say, it's pretty likely that at least one dinosaur evolved live birth. There are quite a few dinosaur lineages that we haven't found eggs for yet. So the two simple answers there are either we haven't found the eggs yet because they don't preserve, or we just haven't found them, or they give birth to live young. And the only way to really settle that debate is finding a fossilized pregnant dinosaur to prove it. which would be one of my favorite discoveries of all time if that ever happens.
That would be cool. And that wraps up this episode of I Know Dino. Thank you for listening. If you want easy access to our show notes and other dinosaur news and articles, then go to our website, iknowdino.com, and you can sign up for our newsletter. Thanks again, and until next time.
Good day.